Hello, and welcome to the Taos MosesCore online tutorial on machine translation and Moses. My name is Barry Haddo, and I'm a postdoctoral researcher at the University of Edinburgh. In this module, I'm going to introduce you to the Moses machine translation system, explaining what it is and what it does, as well as giving some background on Moses' origins and community. So what is Moses exactly? Well, Moses is a software toolkit for creating statistical machine translation systems and for translating using those systems. It contains most of the tools required to build a translation system, and it easily integrates with the required external tools. So in principle, all you need to do is add data. Moses is created and maintained mainly by MT researchers, so it implements all the state-of-the-art approaches to SMT, for example, phrase-based, hierarchical, and syntactic machine translation. Is licensed under the LGPL, or Lesser General Public License. So no restrictions are placed on its usage, whether academic usage or commercial usage. The Moses Toolkit is probably the most complete in terms of its coverage of SMT technologies, as well as being the most widely used open source tool. The history of Moses really goes back to Philip Cohen's work as a student in ISI in Los Angeles. He was one of the originators of the phrase-based approach to SMT, and developed a phrase-based decoder called Pharaoh, but it was never released as open source. After Philip arrived in Edinburgh, his student Hugh started working on an open source successor to Pharaoh, which would explore the factored extension to phrase-based machine translation. This is a way of adding extra linguistic knowledge to phrase-based machine translation. The new translation system was named Moses, since he was the one to lead the chosen people away from the Pharaoh. The following year, the 6-week-long workshop at JHU propelled Moses to a first release of code on SourceForge. Since then, Moses has been supported by the EU under various projects, principally Euromatrix, Euromatrix Plus, and MosesCore. The funding has also enabled us to support an annual 1-week hackathon, the Machine Translation Marathon, which was first held in Edinburgh in 2007. Over the course of its development, Moses has continued to increase the range of SMT technologies that it supports, notably adding support for hierarchical and syntactic models in 2010. An important thing to remember about Moses is that it's academic software, in the sense that it is developed, maintained, and supported mainly by academics. In this regard, the University of Edinburgh plays a leading role, but contributions are made from researchers from many different institutions. In the academic world, Moses serves as a platform on which to try improvements to existing methods without having to re-implement a whole SMT system, an enterprise which could occupy many person-years. Moses can also be used as a baseline system, to which new approaches and models can be compared. Having well-supported open-source machine translation software means that small labs can compete with larger labs, as it substantially reduces the amount of work required in implementing a new research idea. The success of Moses in the academic world is indicated by the huge number of citations received by the Moses paper. Moses is becoming increasingly popular in commercial settings and in public bodies such as the European Union. In these organizations, machine translation is often used for post-editing, in other words, as a first pass before being corrected by human translators. The main advantage of using Moses, as opposed to using an external system such as Google Translate, are firstly that Moses can be customized to your own needs, using your own data, potentially giving better results. And secondly, that full control is retained over the translation process, so, for instance, the text does not have to pass to an external server. There's various models in which Moses can be used in a commercial setting. So in the first place, you could compile Moses from source, assemble the supporting tools, and build the translation systems yourself. This requires good Unix skills and some MT knowledge, but offers the maximum amount of control and makes it easier to integrate Moses into your own systems. Another option is to use a packaged version of Moses. These can be obtained pre-compiled for particular platforms and may come with some extra text processing scripts and perhaps support options. If you do not want to run Moses on your own systems, you can also use a hosted version, where basically you upload your data and a translation system is created for you. And finally, you could use some kind of hybrid system, where Moses is combined with other MT systems, for example, rule-based systems. The current development of Moses is supported by the EU through the MosesCore project. MosesCore received funding under the EU's Framework 7 programme to continue to support the development of open-source machine translation. MosesCore involves 3 academic partners and 2 commercial partners. The academic partners are the University of Edinburgh, FBK based in Trento in Italy, and Charles University Prague. They've all been heavily involved in the development of Moses and other open-source language technology tools. The first commercial partner, Taos, are a think tank for the translation industry, and in particular are involved in promoting the usage of Moses. The other commercial partner are ALS, who are a power user of Moses, and also a provider of translations for the shared tasks. These shared tasks allow the comparison of the latest MT systems with the output of human translators. MosesCore consists of 4 work packages, broken down as follows. The first work package is Moses. Essentially, this involves the continuous support and development of Moses, and also the hiring of a Moses coordinator, Hugh Huang, who's based in Edinburgh. The second work package is concerned with MT marathons. These are annual MT hacking events, which also include a summer school, and they'll be hosted at each of the academic institutions in the 3 years of the project. The third work package contains the workshop in machine translation and the shared task which I mentioned earlier. The workshop is an annual workshop in machine translation featuring paper presentations and also a discussion of work on the shared tasks. The final work package is concerned with industrial outreach, and it will involve promoting the usage of open source machine translation at a series of one-day events organised by Taos, as well as developing tutorials such as the one that you're listening to now. Moses has a large and varied developer and user community, and this slide details the main ways in which they keep in touch with each other. If you're looking for help with Moses, then the most direct route is normally through the Moses mailing list. The mailing list is actually quite active and features discussions both on Moses usage and on MT in general. The main Moses developers are regular contributors to the mailing list, but many questions are also answered by other Moses users. Moses also has a fairly comprehensive documentation hosted on a wiki site, and also available as a 250-page manual. It contains useful usage instructions for Moses, as well as tutorials and introductions to the basics of SMT. Of course, like any open source documentation, some parts are in need of, well, care and attention, but the Moses community always welcomes contributions and corrections. The Moses source code is hosted on GitHub, and it's separated into core code and contrib code, with contributions usually being well received and integrated and incorporated quickly into the Moses source. The main event for people interested in open source MT is the Machine Translation Marathon. This is an annual 1-week hackathon and summer school. If you go to this event, you'll find that most Moses developers are in attendance, and also developers of other OSS translation systems such as CDEC, Joshua, and Jane. If you're interested in using Moses, then I think it's useful to understand something about the development process. Moses has been hosted on GitHub since autumn 2011, and prior to that it was on SourceForge using SVN, but we found that GitHub adds more flexibility to the development process. There's no official binary downloads for Moses, so if you go into GitHub, you'll just see a source tarball download. There are binary packages available from other parties, and I'll come back to this later. The way the commit process works is that there's no single gatekeeper, so if somebody wants to commit, they're given commit rights, they're trusted not to break things, and then we check what they've done. And if there's problems introduced into trunk, they're usually fixed fairly quickly. And in fact, trunk stays reasonably stable because any disruptive development happens on branches. If you look at the Moses source on GitHub, you'll see there's actually many branches. This makes it look rather complex, but in fact many of these are forks, so they are branches started by people to do some experimental work, which they decided not to merge into trunk. I mentioned MosesCore a couple of slides ago, and one of the aims of MosesCore is to actually improve the testing and release process of Moses. So this would involve improving the test coverage. At the moment there's some system tests, but there's very few unit tests. And it would also involve actually having annual releases starting in the first quarter of 2013, although in practice we'll probably have releases at least 6 monthly, starting in late 2012. One of the big questions that's often asked about MT is, how fast is it? This is a difficult question to answer precisely, as there are so many variables, but I'll try to give some rough figures here. Times for training and decoding are highly dependent on the amount of data and the hardware, but for training a reasonable system, this can be done on a high-end laptop in perhaps a few hours or overnight. A state-of-the-art system, though, of the sort that a research lab might build for a competition, so that would be using maybe 15 million sentences, in other words 500 million words, could take over a week on a powerful server. As far as decoding is concerned, it's what is technically known as embarrassingly parallelizable. In other words, all you need to do is split the data into batches and decode each batch separately. Moses supports multi-threaded decoding so that it can take advantage of multi-core machines. There's a significant speed up when using multi-threaded decoding, although it's normally less than linear in the number of cores due to some locking overhead. Moses also supports cluster decoding using the supplied scripts for Oracle Grid Engine, and I've seen reports on the mailing list of users having success using Torque. Another efficiency saving is that models can be compiled so that they are loaded on demand. This trades off RAM usage in decoding for disk access. The development of Moses is usually done on Unix-like operating systems, in other words, Linux and OS X. So we find that most people developing Moses use one of these OSs, and most people building translation systems with Moses use Linux. Specifically at Edinburgh, we use OpenSUSE version 11.3 and Scientific Linux 6, but any up-to-date mainstream Linux should work fine. Moses should also work under Cygwin, but a native Windows build is a little bit trickier. The decoder is a C++ application, so in principle could be compiled under Visual Studio and run natively in Windows, and in fact it has worked under Visual Studio in the past with the basic internal language model, but this language model has been removed, and the current default language model, KNLM, uses techniques to reduce memory usage which make porting more difficult. However, there are efforts underway to create a VS build. The training pipeline, though, relies heavily on many Bash and Perl scripts, so it's unlikely to ever run on Windows without Cygwin. It has, however, been reported to run under Cygwin, but this isn't really a common setup, so I think the bottom line is, if you're really interested in using Moses, Linux is the best way to go. This slide is a recap on the types of SMT models that Moses supports. Originally, Moses just supported phrase-based machine translation, although it had the factored extension to phrase-based machine translation since the very beginning. This factored extension can be used to add linguistic information to phrase-based machine translation, for example part-of-speech tags or morphological information. It has been shown to improve the translation of morphologically complex languages, for example Czech and Turkish, to improve local reordering, and to help with the translation of rare words. Support for hierarchical and syntactic models was added to Moses in 2010. This required a new decoding algorithm, chart decoding versus stack decoding, and new extraction tools. Hierarchical models normally give better results when the languages are more structurally divergent, for example when translating from Chinese or Japanese to English. However, the training and decoding of these models can be a lot more expensive. Syntactic models are more of a research area at present, and Moses supports a variety of different types of syntactic models. As I mentioned earlier, Moses contains both core and contributed tools. The core elements of Moses are for training SMT models and for decoding with these models. There are also tools for pre-processing corpora, although Moses really only includes tools for dealing with text in a Latin script. The experiment management system is a way of running SMT experiments with Moses using a configuration file to track the various steps required. It works a bit like a makefile in the sense of backtracking from a goal and only running the steps that are necessary. There's many other tools contributed to Moses and available in the Moses GitHub repository. For example, there's a basic server using XML-RPC to serve translations, which can be used to build an online translation system. There's also various alternative experimental phrase extractors, and there's wrapper strips to help package linguistic tools so that they can be used factored models. The evaluation and analysis tools packaged with Moses can be used to score translations according to various metrics, and also can show how the decoder arrived at particular translations. Finally, phrase table merging is a tool which can be used to combine different tables from different sources, applying different weights to them, and phrase table filtering is a lossy compression method used to reduce the size of phrase table by throwing away entries according to statistical tests. The diagram on this slide shows the typical training pipeline for phrase-based MT. Other approaches to SMT have similar training pipelines, although the corpus preparation steps do change a bit when using non-Latin scripts. Let's step through the training pipeline. Assuming we start off with sentence-aligned data, the first stage is to tokenize, in other words, to split up the sentences into individual words and punctuation symbols. In the cleaning stage, long sentences and clearly wrongly aligned sentence pairs are removed and Moses special characters are escaped. After making the casing consistent, the parallel data is word aligned by an external tool and the target side is used to train a language model. The word alignments are used to create a phrase table and optionally a reordering model. The longest stage, which is known as tuning, is used to weight the different models against each other. The output of the training pipeline is a set of weighted models forming the overall SMT model. Once you have a trained SMT model, you're ready to decode with it. There's two different decoder binaries, i.e. applications, in Moses. The first one is simply called Moses, and it implements stack decoding, as used in phrase-based MT. The second one is known as Moses Chart, and it implements chart-based decoding, as used for hierarchical and syntactic models. Both of these decoders can be run in batch mode, in other words parsing in the file full of sentences to be translated, or in interactive mode, in other words typing in sentences at the command prompt. Both of them also support multi-threaded and multi-core, in other words cluster-based operation, and the Moses server can operate on both types of models. There's a few tools required to build translation systems that Moses delegates to third-party applications. Firstly, Moses does not provide a word aligner, since there are good word alignment tools available under liberal open source licenses. The scripts controlling the Moses training pipeline allow word alignment to be delegated to either Giza++, which is the usual aligner, or the Berkeley aligner. These both implement fairly similar alignment models, so using one or the other makes little difference in practice to the final translation results. Language model estimation is another essential task in the building of an SMT system. The best known language modeling toolkits are ErstLM from FBK and SRILM, but the latter charges a large fee for commercial use. The Moses training scripts enable the incorporation of either of those language models. Moses does not provide pre-trained models, although these are actually being prepared and will be available shortly. One of the big advantages of using Moses is the possibility to train your own models, which is partly why pre-trained models have not been made available until now. Finally, there are no tools in the Moses toolkit for the processing of non-Latin languages, for example for segmenting Chinese, but these are generally available from elsewhere. So what do you do if you don't want to go to the bother of building Moses from source and assembling the rest of the toolchain yourself? Well, actually there's plenty of other options. On this slide I show some examples of packaged version of Moses, and I should point out that this list is by no means exhausted. These packaged versions come in many variations and in two distinct flavors. The first type of packaged version is an installed solution. And what I mean by this is essentially just a binary package. So you download a pre-built package for your operating system, which takes care of all the dependencies for you. All you actually have to do is add data, and many of the packages make it easy for you to process the data by providing extra tools. A second option is to use a hosted solution. In this scenario, Moses runs on a remote server, you upload your data to this server, and a trained system is then produced for you. This presentation has only been a very brief introduction to Moses. If you want to learn more, I suggest that you check out the sources of information on this slide. The first port of call should always be the Moses website, where you can find answers to many of the questions you may have about Moses and details of all its features. For questions not addressed on the website, there's always the mailing list. This mailing list is very active and questions rarely go unanswered. There's a big range of discussions, from basic questions on getting started with Moses through tool usage, bug reports, and discussions about MT theory. And finally, Moses is also occasionally on Twitter and even on Facebook. Maybe we'll see you there. This is the end of the Moses introduction tutorial. For further tutorials, go to the web address shown in this slide. Thanks for your attention.